Okay, so we are getting into angles and triangles, okay? What do you guys know about triangles?
I have three parallel lines.
Not
Or
necessarily.
not parallel, sorry, what's the other word for it?
Three sides.
Yeah.
Three- But they're not always the same length, right?
Yeah.
Because you can have like a scalene or an isosceles, or what's the third type of triangle? Equilateral, right? Yeah.
That one.
Right? Yeah. Yeah, equilateral triangles have all of these same lengths for sure. But yeah, so they all have three sides. What else do we know about triangles?
They're the strongest shape in the world.
They are. They are. They are the very strongest shape in the world. So that's why they're used in lots of construction, lots of bridges. Yeah, very strong. What do we know about angles and triangles?
90 degrees. 180.
180 degrees, yeah, good. And if it's a right angle triangle, it has one angle in there that is 90 degrees, right? Is that what you're thinking of? Yeah, perfect. So we have right angle triangles, we have scalene, isosceles, equilateral triangles, good. And they're strong, good. Okay, we also have lines, right? Parallel lines and a transverse line. So what does parallel mean?
They're the exact same length and same way far apart.
Do they have to be the same length? No, they do not.
Oh,
They do not need to be the same length. But what else did you say? Like kind of like the same length apart? Yeah, okay. Same length apart. And do they touch? They never will touch, right? They will never touch. They go on forever and ever and ever and ever. Okay? So parallel lines, if you see little notes like that, that means they're parallel. Okay? Those are parallel lines. Good. What about parallel parking? Some of you guys had to do driver's tests. How do we feel about parallel parking? Do you guys know how to?
I'm the best.
You're the best.
Logan,
I think
you could
they
not park it.
ball. You
I
can't,
can-
you
I'm-
can't even
yeah,
drive
he's-
properly.
he's-
Those
yeah,
kill
Brendan,
me
you don't have any
twice.
Yeah, I
license. You
know.
don't have a say in
No,
this.
but-
The amount of times you've almost killed us just at life.
Exactly. We almost got T-boned. We were paying attention.
I was in Banff a couple of years ago, and it was like in the middle of the summer, so it was like super busy.
Yeah.
So hard to find parking spots in Banff, right? So, anyways, my buddy and I were driving around, we're looking for a parking spot, and I see one. It's like, it's pretty tight, but it's like my car could fit in there. I'm like, yeah, I'll fit. So seriously, and yeah, it was tight. So I go up, get like, mirror to mirror, get your like back end to back end, and the road, like 45 degrees, and then you twist back in.
Yeah.
Seriously, I'm like not even trying to put my own tires. It was like a 10 out of 10 parallel parking job. It was like perfect, good leg from the curb.
Yeah.
Like it was really good. It was so good that I honestly couldn't even get out. Like driving regularly, I actually I barely bumped the truck in front of me as I was trying to get out because it was like so tight.
Yeah.
That was the best parallel parking I've ever done. I don't think I've ever done it better than that, and it got me into trouble because I got stuck in there. But yeah, so parallel parking, parallel lines, right? Good. All right. And triangles have interior angles equaling 180 degrees, always, okay? Good. Have a little joke here for you guys. So, parallel lines have a lot in common, but they never meet, ever.
Right.
You may think that's sad, but every other parallel lines meets once, and then drifts apart forever, which is pretty sad too. Huh?
That's kind of depressing.
It's kind of sad. Yeah, I just thought that was funny. So we were supposed to start off with this unit, but just in case students were coming in from Dash 2, we did the expressions units first. So I've been sitting on this little image for like 3 months now. It wasn't the reaction I was kind of expecting, to be honest. Anyways, so math jokes. Okay, So we are going to talk more about this stuff tomorrow. Okay, I just wanted to introduce it today. And I'm probably going to draw something like this up on our whiteboard. Okay, we're going to take down our equations and stuff. Okay, so we will have this. But yeah, so let's just take a look at this stuff. Is it refresher from prior years?
Some of it.
Like alternate exterior angles, corresponding angles, same side interior. All of these are going to be with respect to a transverse line, okay? So a transverse line is just a line that intersects two lines, okay? They do not have to be parallel, but transverse line just intersects two lines, okay? So this case right here, this is my transverse line right there, okay? So this is a transversal, and alternate exterior angles are those that are on opposite sides of the transversal and are on the outside of the other two lines. Okay? So those are, and don't worry too much about writing this stuff down. We are going to learn more about that tomorrow. Okay? I just wanted to introduce this. Corresponding angles, these have the same relative position and angle. Okay? We have alternate interior, so these are going to be on opposite sides of the transverse line. Same side interior angles are on the same side of the transverse line. Okay? And again, same side exterior angles are on the outside of the parallel lines and on one side of the transversal.
Yeah.
Okay?
I'm gonna go get my water.
Yeah. Okay? So anytime that you have like angles, it's going to be usually with respect to a transverse line. Okay? And that is just the line that intersects two things. Okay? And we will learn more about this tomorrow. Okay, so this brings us to our Kagan activities K. So, do you guys have like a compass and protractor set and stuff like that? No? That's okay. You don't have to. Part of this unit is like drawing parallel lines and bisectors and stuff like that, and I don't think that we need to do that. So don't worry too much about that, okay? But just make sure you guys are able to do some of this stuff, okay? So, on a straight edge, I'll measure it up here, and you guys are just going to follow along with me, okay? So this is on activity 1 of the Kagan. Okay, so on your sheet of paper, draw two intersecting lines. So you guys can just sketch like two lines, okay, that intersect, kind of like what we have up here, okay?
It's already on ours.
It's already on yours, okay, never mind me then. Okay, and now what we're going to do, we're going to measure our angle. So we want to make sure that this line is nice and straight. And then you also want to have it kind of as close to that middle as you can. Okay, I think that's pretty good. Okay, and then we're going to go, oh, I moved it. And then we're going to go and measure this angle now. Now I just got to remember how to do it. There we go. Okay, so our angle coming from the opposite side. Hey, come back here. Okay, so coming from here and going up here, it is what, like 125, 126, let's say 128. So angle 2 is 128. $128, okay? So now let's take this, and we're also going to measure angle 4.
Oh, you drew that half circle thing? That's really perfect. It's kind of insane.
What thing? Sorry.
That red dot line.
Oh, but not intentionally. Okay, so same thing, we're gonna set that up here, and voila, look at that. So angle 4 is also, and I kind of like, it's hard to move it on the smartboard, I'll move it back over here. But if I measure angle 4, albeit it is also 128 degrees. How about that?
No way.
How about that? So angle 4 is also equal to 128 degrees. Yay. What degree do you guys think angle 3 and angle 1 must be?
128 degrees.
128?
Yeah.
Angle 3 and angle 1?
No. I think it's something else.
So,
Because, yeah.
so we know
I
this,
remember.
and this is 128 degrees, right?
It's going to be less than 128 degrees because it's going to the left. So it'd be like under 90 degrees, I think.
Okay, sure. I like that. Any other comments regarding that?
No, I have no idea.
No?
No.
Okay, well, let's just measure it then, if we're not sure.
Oh, wait. What the?
Okay, so I'm going to put that nice and close. And now, let's measure this. So we got like 52 degrees is what that reads. You guys see that? That says 52. Okay, so angle 3 is 52 degrees. Which is good. So if we know, get out of here. There we go. Okay, so if we know that angle 3 is 52 degrees,
Angle 1 is 52 degrees.
angle 1 is also 52 degrees. Yeah. Good. 52 degrees. And Brody's punching numbers. What did those add up to?
360.
360. It's all of them, right?
You got it correct.
So that's perfect, right? So
Did they actually add up, Brody, exactly to 360?
a whole circle will have 360 degrees in it, right?
I'm just shocked we had exactly the right numbers.
So what if, so that was for the whole rotation, right? So let's say we're starting here and we're going all the way over is 360 degrees. And that makes sense, right? When we're like watching like X Games or something like that, right?
Wow,
People can do like 1080s, like 1080 McTwists.
McTwist? This is something.
That sounds like an ice cream treat. that you
That's,
give.
I forget his name. Sean
Sean
White?
Yeah,
Oh.
Sean White.
Sean White snowboarder, yeah. When I was your age, that was like the big movie, like the 1080
Yeah.
or the 1060 McTwist, yeah. Okay, so that was going the whole way around. What if I only wanted to go halfway?
That would be 180.
It'd be 180. 180 degrees, good. And what kind of line is this one?
Intersect.
Well, is it curved?
No.
No, it's straight, right?
Yeah.
So, rule of thumb, okay? A straight line, like this, will always have 180 degrees. Okay? So if you know, let's say you know that one angle is, this is like, let's say 105. What must the remaining angle be here?
Say that again, sorry?
If a straight line is 180 degrees,
Yeah.
Did you say 10.5 or 100?
105.
Okay.
And this green line has an angle of 105.
That other angle would be 75 degrees.
Yes, perfect. Okay, good. So then our other angle will be 75 degrees, right? Because those two angles must equal 180 degrees, right?
Yes.
Is that okay?
Oh, yeah.
Yeah? Okay. Excellent. Okay, so let's answer some questions here. So if you measure the angles of 2 and 4, what are their relationship? Well, angle 2 and angle 4
Or the same angle.
are the same angle. Good. Okay? So what appears to be true? Angle 2 equals angle 4. Okay? And that's just saying angle. Okay? When you see like this thing here, that means angle. Angle 2, angle 4. Okay? So angle 2 equals angle 4. Do the same thing for angle 1 and 3, which we did. What is their relationship?
Angle 1 equals angle 2.
Angle 1 equals angle 3. You bet.
Or 3, yeah. Sorry.
And summarize our findings in a complete sentence. So what is the relationship between 2 and 4? Like, where are they located?
Up across from each other.
Across or opposite? is what we're gonna say. Okay, opposite. And then 1 and 3 are also opposite, right? So our conclusion is that opposite angles are always equal. Opposite angles are always equal.
Can I use the washroom real quick?
Mm-hmm.
Can I borrow a pen or pencil? My run out of lead, and I don't have any.
Come on, Brandon.
You guys, I don't even have any pencils to spare. Guess you gotta write in blood.
Blood? Is that what you said?
Yeah.
Blood? Oh, okay, shit.
So, that was actually a really good throw.
Can you do that, Brody?
Yeah.
Brody.
Have you guys ever seen The Simpsons? And I refer to this a lot. Sideshow Bob, when he's like in prison and he doesn't have a pencil or a pen, he like pokes his finger with a pin and writes his letters in blood with his finger.
Don't think I've seen that episode.
No, it
Asked you, keep telling me.
Okay, so opposite angles are always equal. You bet. Okay, moving on. So using a straight edge. So we're gonna do this again. So let's label our angles like the diagram shown below. So I'm just gonna jump back up and steal this protractor. It's back. All right. So what are we gonna do? Measure angle 1 and 2. Okay. So gonna get close as I can. Gonna bring that down. And then here's our angle right here. It's like, let's say 49 degrees. Okay. So angle 1 is 49 degrees. Can you guys write that down, please? And remember that for me. Okay, so if angle 1 is 49 degrees,
Yeah.
then angle 2 is 121 degrees. Angle 1 is 49 degrees, and angle 2 is 121. Good. Okay, so let's go ahead and we'll
I
measure.
don't think that's correct.
I'm gonna be 131.
Oh,
Yeah, so we only got 140.
okay, fine. 131. So how did you know it was 131?
Because we only equaled 140.
Okay, say that again.
I only got, add them all together, I only got to 140.
And what should we expect to add up to?
340, and I should have got 360.
Oh, because you added all of them up? Okay, so let's just look at the relationship between 1 and 2. Okay, so you wanted it to be 131, because if you added 49 and 121, we only got 170, right?
Yeah.
So, and again, a straight line has an angle of
180.
180. Okay, good. So that's perfect. Okay, so then, based off of what we learned from last slide, what did we learn from last slide?
That opposites equal each other.
Yeah, opposite angles are the same. Okay, perfect. So if angle 1 is 49 degrees, and angle 2 is 131 degrees, then angle 3 is the opposite of angle 1, which means angle 3 is
49 degrees.
also 49 degrees. Good. And that must mean angle 4 is 131 degrees. You bet. Good. Okay, so measure angle 1 and 2. We did. Okay, based on your knowledge of vertical angles, fill in the measures of angle 3 and 4, which we did. Okay, number 5. Find the following sums. Okay, so what is measure of angle 1? So that is 49 degrees. And then we're adding angle 2, which is 131. and that is going to equal 180 degrees. Perfect. Angle 2 is 131, and angle 3 is 49, which equals 180 degrees. I'm just going to move this. Angle 3 is 49 degrees, plus angle 4, which is 131. It's equal to 180 degrees. And lastly, angle 1 and angle 4. So angle 1 is 49 plus angle 4, which was 131. I think I mixed one up, maybe? Angle 3 and 4? No, that's okay. And that also equals 180. So what appears to be true?
They're all equal up to the same value.
Yeah, and what value is that?
180 degrees.
180 degrees. Perfect. So what appears to be true? They all equal 180 degrees. And write a sentence summarizing our exploration. So what's a statement that is true?
A line must equal 180 degrees.
Perfect. Yeah.
Correct.
Yeah, good. So let's see, what do we put here? So angles that add up to 180 degrees are called supplementary. Okay? So that's important. Make sure we know that definition there, supplementary, okay? And we can also say two angles on a straight line add up to 180 degrees, and that is termed supplementary. Okay, so write those sentences down, please, if you have not done so. Okay, so angles that add up to 180 are called supplementary. Does anybody know what angles that add up to 90 degree are called?
Acute? I don't know.
No.
That's if they're like below like 90 degrees.
Yeah, if your angle is smaller than 90, then it's acute. It's an acute angle. It's low. Angles that add up to 90 degrees are called complementary. And the way that I remember that, so a 90-degree angle is a right angle, right? So they complement each other, and then they make one another right.
Oh.
Yeah, I know it's stupid. But that's honestly helps me remember things, is doing little stupid, sayings like that, so. Okay, moving on. Okay, so we know complementary and supplementary angles now, okay? Perfect. So you guys are going to be doing some algebra and some angles, okay? So for each problem, we're given like a general thing like this, okay? Now, when we're solving them, they're going to be different each time,
Yeah.
okay? So just don't get thrown off by that, okay? So like for some questions, the angle of, well, let's just look at this, okay? The measure of angle 1 is 4x plus 3 for question 1. But for question 2, the measure of angle 1 is 2x minus 7, okay? That's okay. Each question is going to be different than the last one, okay? So this measure of angle 1 is not always 4x plus 3. It changes per question, okay?
Could you not just go take the angle of number 2, figure it out, say it's like 160, or it probably won't be that high, but say it's 160. You add those both together, so you have 240, Then you just go 360 minus 240 and you get an answer divided by 2.
That's essentially what we're doing. Yeah. Yeah. So yes, to answer your question, you can do stuff like that, okay? But I just wanted to let you guys know when you are doing this, you're given like a one thing, right? And it's going to be different for each question, okay? So just be aware of that. Okay, so for each problem, so there are 5 steps for each problem, okay? So step 1, state what type of angles the given angles are, okay? Are they complementary? Are they supplementary? Are they opposite? Okay, that's your first step. And then B, state the relationship of the angles, write an equation, solve for x, and then find the measure of the angle requested, okay? And the diagram is not drawn to scale, it's just like a general image to help us kind of visualize it, okay? So, number 1, so angle 1, so will be red, I guess, okay? And angle 3 can be green. Okay? So, what are the relationships of angle 1 and angle 3?
They have the same value.
Okay, but
Agree.
yeah, you're right. But let's use our terminology from the beginning of today.
Opposites equal each other.
They're opposite angles, okay? So we say M1 and M angle 3 are opposite. Okay? And like you said, Logan, or maybe it was Cody, or maybe it was Brody, what do we know about opposite angles?
They always equal each other.
They equal each other, okay? So therefore, measure of angle 1 is equal to the measure of angle 3. Okay? So you guys should be following along, writing this down, okay?
Ours is different than yours,
Oh yeah, it is.
but way different.
Yeah.
We have
How much
6
space on
examples.
Yeah, because we're doing the first 2 together, and then you guys are doing the rest on
Oh,
your own.
yeah.
Okay? So, and you guys should be doing this on a spare sheet of paper too. Okay? Because there's not enough room to do your work. So, do you guys need paper?
Yeah.
Logan, Brody, you too? Okay, so step 1, we are looking at our angles, right? What type of angles are they given, and what is their relationship? So they're opposite angles, therefore angle 1 equals angle 3. Okay, we're all good so far? Okay, we know measure of angle 1 is 2x minus 7, and the measure of angle 3 is 3x plus 17. Okay? So step 3 was write an equation, which we have here. Maybe I'll do our steps. So 1 is relationship of the angles. 1 is what angles they are. 2 is the relationship. 3 is writing an equation. 4 is solving for x. Okay, so to solve for x, we need to get x to one side of the equation, right? So this x is bigger than that x, so I'm going to subtract 2x from both sides. Okay, now we're isolating for x, so I'm going to subtract 17 from both sides. Okay, so 3 minus 2x just gives us x is equal to negative 7 minus 17, x equals negative 24. Okay, so now we have just calculated what our x is, and now we need to find the actual angle of 2. Okay, so now we're going to substitute in our x value into angle 2. Oh, well, why did I do them for opposite angles? Huh. That's silly. Okay. Because M1, M3, we are doing it for M2. So, you guys just want to solve this one for M3? Because we're already at this point?
Yeah, sure.
Okay. So we'll just say M angle 3, M angle 3. Yeah. I don't know if this can work, but we'll see. Okay, so now that you have solved for your x, you're going to substitute that into your whatever you're trying to look for, right? So in here we're looking for a measure of angle 3. So it's going to be 3x plus 17. And we're substituting it at x equals negative 24. Okay, so 3 times negative 24 plus 17 is equal to what? 24, 48, negative 72 plus 17, 62. You guys have the calculators. Three times negative 24 plus 17.
55.
55.
Negative 52.
Yeah. So we can't have it. Well, I guess we could have a negative angle. Sorry, I messed that one up because I did the wrong thing. But that's what you would do. Okay. These are your steps. Okay. And just disregard the negative for this one because I made a mistake. Sorry. But we will fix it for the next one. Okay. So what are the relationship? Okay. Make sure we know what angles we're doing. Okay. And then you're going to make an equation, solve for x in your equation, and then find the value of, this would be measurement of angle 3. Okay? No, because I was looking at the wrong one. Oh, golly. Mr. Jones. So I guess that would have worked out anyways. Sorry about that. Okay. Questions? Concerns? Are we feeling okay? Okay. So, yeah, so we did do it right the first time. It was measure of angle 1 and measure of angle 3. Those are opposite. Okay. Now, let's do the right one. So for our second one, we're going to do with measure of angle 2. Okay? Are you guys good with this stuff right here? Yeah? Okay, so I'm just going to erase it. And we'll leave our steps up there. Okay, so now we are dealing with angle 1 and angle 2 right here. Okay, so what is the relationship between angle 1 and angle 2?
They equal 180.
Yeah, they equal to 180.
Yep, and what do we call those?
Supplementary.
Supplementary, okay. So we will say angle 1, measure of angle 1, and measure of angle 2 are supplementary. Therefore, add up to 180, right?
Yeah.
Okay, so second step, we're going to, we've done a relationship. Okay, now we are going to, what do we do? We did the relationship, what the angles are, so they're supplementary, and they add up to 180. So now we need to write an equation. Okay, so if they're going to add up to 180, so we do measure of angle 1 plus measure of angle 2 equals 180. Okay, so now step 3 is going to be solving for x. So let's put in our values here. So measure of angle 1 is 2x minus 7 plus measure of angle 2, which is 3x plus 17, is equal to 180. Okay? And we are solving for x, right? So what's the first thing that we're gonna do, Logan?
Okay, so we're solving for x. I'd say cancel out 2x.
With what?
Negative 2x.
Okay,
Alright.
why would you do that? So we're just gonna have an x on each side of the equation,
Yeah.
right?
And
But I like how you want to do something with that 2x. We also have a 3x here, right? On the
yeah,
same
then
side.
We do that to the other 2x because
So,
we subtract 2x from 3x.
but it's 2x plus 3x. So let's combine like terms,
Okay, so
right? So then it's 5x, right?
Yeah.
Okay? We are getting the x's by itself. So what should we get to the other side of the equation?
The negative 7.
Yep, okay. And how do I get that negative 7 over there?
Negative
Add 7.
Add 7. Okay, so this goes away. What else do I need to get rid of?
The positive 17.
Good. And how am I going to get rid of that?
Subtract it.
Good. Okay, so now, after all of that, I will have 5x, right? 2x plus 3x is 5x, right, Logan?
Yep.
Okay, and then I get 180 plus 7, so which is 187, minus 17, which is 170. Last thing I need to do is divide by 5.
170 divided by 5. I'm going to go on a rant and say that is 32.
Close.
31.
Alright, 34.
34.
I think
Let's find out.
it is 34. Yeah. Okay, so we know our x value. Are we done here?
I'm going to say no, but I don't know why.
Good. We're not. Our last step is to find the measure of angle 2, right? So we've just found our x value. Now we need to plug that into the measurement of angle 2. So 3x plus 17 at x equals 34. So then we go 3 times 34 plus 17 is equal to what?
34 plus 17.
3 times 34.
Oh, 60, 90, 120, 124, 128, 132 plus 17 is 140, 159,
Too much.
149.
Too much.
What?
119. 3 times 34 would
Oh,
be...
it's not 120. Yeah.
Okay. Alright. So we'll stop there, and then you guys are going to have some practice to work on the remainders, okay?
Okay.